Hi everybody, this is a bonus lesson. If you're going on in math, then knowing the special triangles, the exact values of 30, 45, and 60 degrees makes life easier when you get into calculus. I will not test any of this for Math 12, so if you are only doing this for Math 12, no need to go any further, close the video. However, if you're going on, then it is important. Page 531, we're going to skip past the first page. Second page, they make this overly complex. These are the special triangles. I don't write them that way. Those look more complex than they need to be. So we are going to start with where they come from. So if I create a equilateral triangle, so all sides are the same, we're going to make all sides 2. All right. And then if all sides are the same, it means all angles are the same. 60, 60, and 60. And then because we're doing right angle trig, what we do is we drop a line down like that and create right angles. So we create a triangle. We're just going to look at this half here. This side is still 2. This angle is still 60. This angle here gets cut in half. So it's 30. And this is a right angle. If it's 2 all the way across and we cut it in half, this little bit is 1. And then if you use Pythagorean theorem and you do a squared plus b squared equals c squared, or in other words, c squared minus b squared, gives you this side, this becomes root 3. You can check that on your own. That is our first special triangle. The second one is very simple. 90, 45, 45, 1, 1. Those sides have to be the same because the angles are the same. And if you use Pythagorean theorem, you get root 2 here. These are the special triangles. If you remember these two triangles, you don't have to remember the unit circle, which you will see in a bit, and it's a bit of a gong show. And you use the cast rule, you can answer every question that says unit circle in it. All right, so we're going to flip the page. And this is creating the unit circle. We are not creating the unit circle. I'm going to talk about it, but we're not going to use it. So let's draw our special triangles again, and we're going to complete this chart down here. Okay. So this is a good practice for you to remember them. 1, 1, root 2, and that's for 45 degrees. And 2, 1, root 3, that's 30, that's 60. There you go. So we can complete this chart. So don't worry about zeros, we're going to do that in a bit. Sine theta of 30 degrees, or pi over 6. So what you do is you go to your special triangle. Sine of 30 is, sine is opposite over hypotenuse. So it's 1/2. Okay? Sine of 45. Go to 45. Opposite over hypotenuse. So it's 1 over root 2. But if you were to rationalize it, it would be root 2 over 2. I don't really care which way you write it, but in all textbooks, they'll rationalize it as root 2 over 2. 60 degrees, again, go to the 60-degree angle triangle. Sine, opposite, root 3 over hypotenuse 2. So this is root 3 over 2. No need to rationalize because the radical's in the numerator. Sine of 90, we'll deal with that one in a sec here as well. So cosine of 30, go to 30. Cosine is adjacent root 3 over hypotenuse. So root 3 over 2. Cos of 45, adjacent 1 over 2, or root 2, sorry. So it's 1 over root 2. Again, you could rationalize it. And cosine of 60 is adjacent over hypotenuse, so it's 1/2. Okay? And you can see there's a connection. Sine of 30 is equal to cosine of 60. Cos of 30 is equal to sine of 60. And sine and cosine of 45 are the same. Tan, again, do the same thing. Tan of 30 is opposite over adjacent, so it's 1 over root 3. Again, you could rationalize it as root 3 over 3. I don't care. Tan of 45 is 1 over 1, so it's just 1. And tan of 60, look here, tangent is opposite over hypotenuse is root 3. Okay. Now, what are we really doing here? So, one thing about the unit circle, first of all, when you see the words unit circle, it means the radius is equal to 1. All right? So, if we draw a little section of it here, draw an angle here, and it's on a circle. Whoa, on a circle. Okay, that's the worst circle in the history of circles, but there. This is my radius, and it equals 1. What the hell? Equals 1. This is my x value, this is my y value going up, and this is my angle theta. So if we do 0 degrees, that means we have not rotated at all. So our line is lying right on the ground here. And that is 1 because that is the radius. Sine is opposite over hypotenuse. What is the opposite side here? There is no height, right? Usually it would be sine is y over r. So in this case, sine, I'll just write it here, is sine theta is y over r. You can see that from this triangle here, opposite over hypotenuse. The hypotenuse is 1, and the y value, because we didn't rotate it all, is 0. So you actually get 0 over 1, which is just 0. So sine of 0 is 0. That's why it's 0. Cosine, what is cosine? It's adjacent. Cosine of theta is the adjacent, which is x over the hypotenuse, which is r. What's my x value here? It's 1. What's my r value? It's 1. So it's 1 over 1, which is 1. And you'll see when we learn the graphs in lesson 6, this actually is way easier to deal with in terms of these basic numbers. And tan of theta, now, tan is opposite y over x over adjacent. So it's y over x. Our y value, because we did not rotate up, is 0. Our x value is 1. 0 over 1 is 0. So tan of 0 is 0. All right. Now, the 90 degrees gets a little weird. So we're going to redraw this. I'll do an orange. I'm just going to draw this over here. Well, no, I can do it here. If we go to 90 degrees, that means we are straight up and down. We are straight up and down, which means our x value is equal to 0 and our y value is equal to 1. Okay, so let's do sine of 90. Sine is y over r. Our y value is 1 because it's straight up and down. Our r value is 1 because it's a unit circle. So it's 1 over 1, which is 1. Cosine is x over r. Our x value is 0. So we haven't gone left or right. There's no shift left to right when you're at 90 degrees. So it's 0 over 1, which is 0. And then tan, the reason you've known about this on your calculator always tells you, but here's the reason why. Tan is y over x. Our y value is 1. y over x. Our y value is 1, our x value is 0. And you cannot divide by 0, so tan of 90 is undefined, and that is why it is undefined. All right, flip the page. There is your unit circle. All right, everything has a radius of 1. They tell you the reference angle, that would be 60 degrees, and they tell you the coordinates. Now, why are there coordinates? It's because, remember from the second lesson, I think it was, sine theta, and we just talked about it. Sine theta is y over r. Remember, if you're here, there's your y value, there's your x value, there's your r value. That's theta. Sine is opposite over hypotenuse, y over r. But remember, in the unit circle, r is 1, so it's just y over 1 or y. Cosine is x over r, but r is 1, so cosine is equal to x. So what this means is every point on the unit circle, only the unit circle, can be written as cosine of the angle, sine of the angle, x, y. All right? Don't worry about these identities. We will deal with those later on. So this leads us to answering questions. Okay. So use the unit circle to find the exact value. When they say exact value or unit circle, they're talking about special triangles. So I always sketch them. Now, these are all 300 degrees, okay? Rotation angle of 300 degrees. So I'm just going to quickly sketch that. So that means we're in quadrant 3. That's 300 degrees, which means our reference angle is 60 degrees. So we can use the reference angle to figure out the answers to all of these questions. And so we need this special triangle. It has a 60 degree in it. 60 is there. 2, 1, root 3. Just for completeness, I'll put the 30 in there. Sine of 300. So essentially, that's the same as sine of 60, but we are in quadrant 4. Is sine positive or negative in quadrant 4? It is negative, because remember, it's add sugar to coffee. Only cosine is positive in the fourth quadrant. So sine 300 is equal to negative sine of 60. Sine of 60, opposite over hypotenuse, is root 3 over 2. So this is negative root 3 over 2. Now I know that seems like a lot of work, but when you get good at this, you'll be able to do that quickly in your head. Cosine of 300, again, we are in the fourth quadrant. Cosine is positive in the fourth quadrant, so it's going to equal cosine of 60. Cos of 60 is adjacent over hypotenuse, which is 1/2. Tangent of 300, tan is negative, so it's going to equal negative tan of 60. Tan of 60 is opposite over hypotenuse, or opposite over adjacent, so it's negative root 3. Root 3 over 1 if you want, but negative root 3. And then for the reciprocals, you just flip all your answers. Cosecant is 1 over sine, so I just take the sine one and flip it, so it's negative 2 over root 3. If you wanted to rationalize it, for those of you that care about those sorts of things, multiply top and bottom by root 3, so you would get negative 2 root 3 over 3. Secant 300 is the reciprocal of cosine, so that's just 1 over 1/2, which is just 2. And for cotan, flip this negative root 3, so it becomes negative 1 over root 3. Rationalize, so multiply by root 3 over root 3, so you get negative root 3 over 3. All right. Use the unit circle to find the exact value of these. Okay. So what is my reference angle for cos of 3 pi over 4? It's pi over 4, which is 45 degrees. Okay. Now, so my reference angle is 45. Now I know this seems like a lot of work, but when you practice it, it just becomes second nature and you can do this in your head quickly. I know 45 degrees. Here is special triangle, 1, 1, root 2. I know that the answer is going to be 1 over root 2. I'll rationalize after. What you have to figure out is which quadrant we are in. In other words, is it going to be positive or negative? Well, we have three 45-degree angles. 45 plus 45 is 90, plus another 45 means we are in the third quadrant. Cosine is negative in the third quadrant, so it's negative 1 over root 2. If you rationalize it, negative root 2 over 2. So tan of 5 pi over 3, what's pi over 3? Hopefully you remember that that is 60 degrees. We have 5 60-degree angles, so that's 300. Okay, so essentially it is this question right here. The same thing. So it's going to be negative root 3 over 3. Tangent of 600. All right, which quadrant are we in? Well, 360 to there, 540 to there. You're going to go another 60 degrees. You're in there. So that means our reference angle is 60. Is tan positive or negative? In the third quadrant, it is positive. So tan of 60 degrees. We use this one. Tan is opposite over adjacent. So it's root 3. And the last one, cosecant of 3 pi. Well, what's 3 pi? 2 pi is to there, so one more pi means we're at 180. Okay? Now we're flat. Our reference angle is 0. So what does that mean? What is cosecant? Let's talk about that. It is running out of room here. Cosecant is 1 over sine of 3 pi. What is sine of 0? In other words, when you're lying down, remember sine is y over r. If we haven't gone up, we're just lying flat, our y value is 0, which means sine is 0. So this is going to be 1 over sine of 0. Sine of 0 is 0, which is 1 over 0, which is undefined. All right, this would be the point in the class where I say, please do questions 2 to 4. So you can try those, and then come back and we'll do the rest of these. Okay, hopefully that went well for you. Or you just scroll down and you're continuing with the video. Either way. Use a calculator to determine. Okay. So what we're going to do, actually, yes, we'll do that. Sorry, people. All right. So use a calculator to determine to 4 decimal places the coordinates of the point on the unit circle that correspond to a rotation of 2 pi over 5. So first of all, you can convert that to degrees if you want, but you don't have to. When we're on the unit circle, remember that the xy coordinates are equal to cosine of your angle and sine of your angle. So all you have to do is just go cos 2 pi over 5, comma, sine 2 pi over 5. Make sure your calculator is in radian mode unless you convert to degrees. But if you're going to plug this in, it has to be in radian mode. And you should get 0.3090 for the cosine one. And then the sine one is 0.9551. So that means you are in, they're both positive, so you're in the first quadrant. And the coordinates at that point are those, x and y. That's your x, that's your y. Okay. Similar type question. We have 2 points, root 2 over 2 and negative root 2 over 2. And q, which is negative 1/2 and root 3 over 2 are 2 points in the unit circle. We rotate clockwise from point P to Q. What is that angle? Okay, so basically draw a picture first. Point P, this is your x, this is your y. Your x value is positive, your y value is negative. So I know I'm somewhere down here. Why does that keep happening? Okay, this is P. Q is negative x and positive y. So negative x, positive y. There's Q. Basically, if I can figure out this angle and this angle, I can figure out what the rotation is. They want to know, what they're asking is, what is that angle of rotation? Well, I know this is 90 degrees, so if I can figure out this, add it to 90. If I know this, I can calculate this bit and just add them all together. Okay. So remember that on the unit circle, so we're going to talk about P right now, your x and y value are cos theta, sine theta, right? Well, you only need to use one of them, so I just use cos, just because. I don't know why, I just do. So talking about P. So what we're saying is cos of some angle will give me root 2 over 2. Now, this is where if you know your special triangles, you don't even have to do anything. I already knew the answer when I first saw this, okay? Because the only special triangle with a root 2 in it is 45 degrees. If you see root 2 over 2 or 1 over root 2, you know your reference angle 45 degrees, which means this angle is 45 degrees. Okay, that's one. Now Q, do the same thing. You know it's going to be cos theta, sine theta. Again, it doesn't matter if you do cos or sine. Find the reference angle. Well, if you're doing cosine, you have to use the negative 1/2. So we're saying cos theta has to equal negative 1/2. Now this goes back. The negative just tells you the quadrant, which is quadrant 2. So really you're looking for cosine of what angle gives me 1/2. Go up here. Cosine is adjacent over hypotenuse. 1 over 2. So it's for 60. So my reference angle here is 60 degrees. So I know this angle is 60. So if I'm going to rotate from P to Q, I'll write it down here. Rotation is going to be 45 plus 90 plus, now if this is 60, what is this angle? It has to be 30, because that whole thing is 90 degrees. So now it's 45 plus 90 plus 30, which is 165. Okay. Oh, everybody loves this question. Logs. Now, ignore the log for now. Focus on this. We want to write that as an exact value. So what's my reference angle? Pi over 4, which is 45, hopefully you said. So really what we're doing, cos of pi over 4. Well, that's 45 degrees. What's cosine of pi over 4? It's 1 over root 2. But it's 7 pi over 4s. So what quadrant are we in? Well, I know there's 2 in each quadrant, 45 degree angles in each quadrant. So it's 1, 2, 3, 4, 5, 6, 7. So we're in the fourth quadrant. Cosine is positive in, yeah, it's positive in the third quadrant. Okay, so we can just leave it as 1 over root 2. So now we have that inside bit becomes 1 over root 2. All right, now hopefully you remember your log rules. As I hear people groaning, what I'm going to do is I'm going to rewrite this 1 over root 2 as 2 to the negative 1/2. The negative because I flipped it up, power of 1/2 because it's the square root. These two numbers match. So my answer is just negative 1/2. Okay, we're not going to worry about that one. We don't need chart should be memorized. Don't need to memorize the chart. People just know the unit circle or the special triangles and waste time. All right. Final bit. Oh, sorry. At this point, you should do 7, 9, and 10. Okay. And then come back. Okay, equation of the unit circle. Really, it's the equation of any circle. Equation of any circle, I'm just going to give it to you, is x squared plus y squared is equal to r squared. Okay? If it's the unit circle, the radius is 1, so it becomes x squared plus y squared is equal to 1. Right? This is any circle. This is the unit circle because it has a radius of 1. Okay. Don't worry about this. Determine which of the following points lie on the unit circle. So basically all you're trying to do, these are xy coordinates. All you're trying to do is put them into here and see if they equal 1. All right? Remember, it's x squared plus y squared is 1. So the first one, I'd go 1/2 squared plus 1/2 squared. Does that equal 1? 1/2 squared is a quarter. Does 1/4 plus 1/4 equal 1? No. So it's not on the unit circle. We're not going to do that one. We're going to do the last one because you can probably guess that it does work out. And there's your x, there's your y. It's negative 2 over 3 squared plus root 5 over 3 squared. Does that equal 1? Negative 2 over 3 squared is 4 over 9 plus root 5 squared is 5 over 9. 4 common denominator, so you just add the tops. I get 9 over 9, which is true because 9 over 9 reduces 1. So this is on the unit circle. Yay. All right. The point P, negative 1/5, and y is on the unit circle in quadrant 3. So they told us this, all right? This is our x, that's our y. I don't like black. Blue. So if they say it's on the unit circle, there's your equation. They give you an x and a y, determine the value of y. Okay, plug it in. Solve for y. So I'm going to get y squared is equal to 1 minus 1 over 25, which is going to be, to make a common denominator, 24 over 25. All right. Oh, that's y squared, sorry. So then if you square root it and reduce it, I don't know what the decimal is, but you're going to get 2 root 6 over 5. Okay? Here's the thing. You're in quadrant 3. So what does y have to be? You got to think about it a little bit. For here, my x was negative, but because we went down, my y has to be negative. So this has to be negative because quadrant 3. Okay? So now, determine the point P lies on the terminal arm of rotation angle theta. Okay, there's our point P. We know these coordinates now. So I'm going to draw them here. Our x value is negative 1/5. Our y value is negative 2 root 6 over 5, or whatever the equivalent decimal is, I don't care. And this is my theta. Determine the exact values of secant theta and cotan theta. All right, well, secant is 1 over cos theta. So what's cosine? Cosine is adjacent over hypotenuse. How do I find hypotenuse? Well, they said this was on the unit circle. So that has to be 1. So it's going to be 1 over negative 1/5 over 1, which if you basically you're just flipping that. So you're going to get secant theta is equal to negative 5. Cotan. All right, that's 1 over tan. So just find tan and flip your answer. So let's do tan of theta. It's going to be opposite, negative 2 root 6 over 5 over the adjacent, which is negative 1/5. Those of you that love fractions, you're very happy right now. Flip the denominator fraction and multiply. 5 over negative 1. 5's cancel. You will get negative 2, or sorry, and the negatives cancel because that's a negative. You will get 2 root 6. That's for tan. So cotan is equal to 1 over 2 root 6. For those of you that like to rationalize, you multiply by root 6 over root 6. So you would get root 6 over root 6 times root 6 is 6 times 2 is 12. That's a lot of work. And now they want to know the angle of theta if you're between 0. So what's the rotation? What is that angle? How did I get there? Okay, well, find your reference angle. Your reference angle. If I know that cosine, or you do tan, doesn't matter. Let's do cosine. I know that cosine, all right, is negative 1/5. Right? Remember when you're doing reference angle, don't use the negative. So I'm going to get, I shouldn't say theta because that'll be confusing with tall theta. Let's say my reference angle is going to be cos to the negative 1 of 1/5, which spits out, don't have that one down. Cos negative 1 of 1 divided by 5. 78.5. Not a nice number. Degrees. So my rotation is 180 plus 78.5. Which is 258.5 degrees. All right, last two questions, people. Determine the equation of a circle with center at the origin and radius of 8 units. Okay, center at the origin, we haven't looked at moving circles. So remember, every circle is x squared plus y squared is equal to r squared. Just in the unit circle, r is 1, so it would be equal to 1. But this one is not. They tell us it has a radius of 8. So it's just going to be x squared plus y squared equals 8 squared, which is really just x squared plus y squared is equal to 64. Whenever you see x squared plus y squared equals a number, that is the equation of a circle. If the point negative 4 b root 3, there's your x, y, lie on this circle, okay, this one right here, determine all possible values of b. All right, plug them in. So negative 4 squared plus b root 3 squared has to equal 64. Negative 4 squared is 16. That's going to give me b squared. Root 3 and root 3 is just 3 equals 64. Move the 16 over. So 40 or 64 minus 16 is 48. So I got b squared times 3 is equal to 48. Divide off the 3. And 16, I don't know why that took me too long to do that. I'm going to get b squared is equal to 16. Square root it, which is plus minus 4. And there you go. All right. Oh, and why would there be a positive and negative? It is because when you are on a circle, so it's going to be up here and down here. All right. Or some other equivalent. Yeah, because your x value is negative 4, so you're out here. So be that one and that one. Okay. This is where I ask you to do questions 11 and 13. And that is the end of this bonus unit. Uh, yeah, if you're going on, good thing to have. If you're not, then you probably didn't watch it anyway. All right. Good luck, people. Thanks.